Hello friends, let's start with a very important chapter, our class 6, chapter 6, which is integers. So integers are so very important because they lay the foundation not only of arithmetic but also of algebra. They are pretty extensively used in all algebraic expressions. We need to do manipulations using integers. Of course, as usual, if you are able to answer these questions, then you are relatively well set with the concepts of integers and you can probably move ahead. If you cannot answer these questions, don't worry, we'll go through them slowly and gradually throughout this lecture, and at the end of it, you will be able to answer them relatively easily. At this point, we are really familiar with whole numbers. So whole numbers, as we know, they start from 0 and they go on until infinity. So we have already understood whole numbers and what they really mean. When we were studying whole numbers, we came across an operation such as this. So for example, let's say that I start with 4 and I subtract 3. So I know that what I have to do in this case is that I would start from 4 and I would go back 3 places and I would end up at 1. So this is what this operation is really doing. Now let's suppose that I want to do, instead of 4 minus 3, 3 minus 4. So this is a valid operation, I can do that. But the problem here is that if I start from 3 and I go back 4 places, so I go back 1, 2, 3, 4, I fall off the number line. So this number line of whole numbers is not really able to accommodate my operation, this 3 minus 4 operation, and I don't know what the answer would be in this case. So this big problem is actually solved by extending the number line. And this extended number line is known as the number line of integers. So what are integers? Integers consist of 3 parts. They consist of all the positive numbers. We know that they are the natural numbers, so they are all positive, and of course they go on till infinity. They consist of all these negative numbers. So what do we mean by negative numbers? The number becomes negative when I prepend a minus sign to it. So for example, this is 1, and if I want to create minus 1, I would just prepend a minus sign to it. If I want to create minus 2, I would just put a minus sign before 2. And all of these negative numbers, again, they go on till infinity, and our integers contain all of these negative numbers as well. And our integers, the set of integers also contains 0. So integers are negative numbers plus 0 plus all the positive numbers. These integers are able to accommodate our subtraction now. That is the most important thing that we should see here. So previously, while I was not able to do this operation, now I would be able to. You will see magically what happens is we start from 3 and we are able to go back 1, 2, 3, 4 places and come to minus 1, and that is of course our answer. But more importantly, we did not fall off the number line of integers, and our 3 minus 4 we will be able to do that subtraction. It might seem like superfluous to just add this entire set of negative numbers just for the sake of it, just to make our subtraction slightly better. I mean, of course, if you think about it, these negative numbers don't seem to have any real use in our life. If I go to a shop, or for example, if I have certain number of pens, I only can have positive quantities of pen. I can have 1 pen, 2 pen, 3 pen. Even 0 pens is okay. If I don't really have a pen, I would say I have 0 pens. But what about these negative pens? How can I ever have negative pens? So these numbers, the negative numbers, don't really seem to have any use, and they might seem superfluous, they might seem useless to us. But that is not the case. They have tremendous application in computers, in mathematics, higher mathematics, which we will be doing, algebra for example, and of course accounting, and also physics. In sciences, they are pretty extensively used. We cannot think of any modern day subject which depends upon mathematics to not have negative numbers. They are so ingrained in our modern subjects. So let's just try to see an example of where this might find use. These negative numbers might find use. So let's say that I have a bank account and it has 5 rupees in it. What I do is that I go to an ATM and I withdraw 4 rupees. You will say, sir, then we would be left with 1 rupee. Of course, that should be our bank balance. We know that. Now what happens if I go to an ATM and withdraw all 5 rupees? Then you will say that, sir, my bank balance would become 0. I really would not have anything in my bank account at that point. What happens if I really have an emergency and for some reason I need 6 rupees. I only have 5 rupees in my bank account, but I need 6 rupees for setting up some industry, for some medical emergency, for something. I need 6 rupees. What should bank do in that case? See, the banks, what they do in that case is that they don't really say that don't withdraw 6 rupees. They allow you to withdraw 6 rupees. But what they say is that your bank balance in that case is not 1 but -1. So it becomes negative. And negative means that instead of bank owing you 1 rupees, you really owe the bank 1 rupee. That's what this -1 says. It is your debt. Okay. So at this point, 5 rupees came from our balance. So this 6 is made up of 5 plus 1. These 5 rupees came from our bank balance, which was 5 rupees, of course. This additional 1 was loaned to us by the bank, and this loan is represented by using negative numbers. So of course, right off the bat, we were able to find out an example where these negative numbers are pretty much very useful. So this is our debt. One of the things at this point to really understand is that both the operation of withdrawal, so if I withdraw, if I take out money from the bank account, or if I take out money from bank account, or if I take debt, if I owe debt, both of those operations reduce my bank balance. Okay, so those are one and the same thing, more or less, essentially, right? Because withdraw money from bank account as well as taking debt from the bank, they would both reduce the bank balance, the balance in my account. What happens if I do opposite? What happens if I deposit, let's say, 1 rupee back into my bank account? So I had a balance, I started with a balance of -1. As soon as I deposit 1 rupee back into my bank account, the bank says that, oh, your loan is now done. You don't owe anything, but you don't have any balance either. That 1 rupee is taken again by the bank to fulfill the loan, that additional 1 rupee that it gave to me earlier. And it says that your bank balance is now 0. So after I add 1 rupee, I don't really get that in my balance that is used to fulfill, to settle my debt. This is the first thing. The second thing is that if I, on top of this 0 balance, if I add anything further, if I make more deposits, let's say that I deposit 4 rupees, then those would be added to my bank account. So if I deposit 4 rupees, my balance would really become 4. So now at this point, we say that both depositing, if I deposit money into my bank account, or if I settle my debt, right? If I'm paying off my debt, if I'm paying it off, both those operations are really equivalent and they increase my bank account. Okay, the balance in my bank account. So those two operations are equivalent. This is what the concept that we would use for rest of this class to really understand addition and subtraction of this on the set of integers, both positive as well as negative. Now that we have understood how to extend the number line, let's look at the various terminologies associated with the number line. Let's look at the various sets of numbers that we have on number line. So here is our set of natural numbers. We all know that they start from 1 and they go on till infinity. That is the first set, the most basic set that everyone understood even before this level. If I add 0 to this set, okay, so starting from 1, I really have natural numbers. If I add 0 to this set, starting from 0 and going in positive direction, I have whole numbers. And then if I add negative integers to this as well, if I add all the negative numbers, negative integers to it as well, this entire set is known as set of integers. And again, if you notice, this number line extends in both directions. So we don't really end at 9, but we go on till infinity, as we did for natural numbers, right, which extended only in one direction but went on till infinity. So do integers. They go on from infinity on this direction and to minus infinity in the negative direction. So those were the first kind of classification we can do of this number line. The second kind of classification that we can do for this number line is that starting from 1, we say that we have positive integers, and we should remember both of these classifications because both terms are actually used in your questions as well, and we should know, okay, these are basic terms. Starting from -1 and going backwards till, of course, minus infinity, we have negative integers, and then we have the number in the middle, which is 0. So 0 is really different, it is separate, but it is included in the set of integers. So integers consist of negative integers, -1 till infinity, positive integers, +1 till infinity, and of course 0 right in the middle. All of those three things. Very, very important. Similar to natural numbers and whole numbers, the number line of integers also has the concept of predecessors and successors. So let's understand it with an example. Consider the number 4. If I go one number below number 4 to the left of number 4, number 3 is the predecessor. One number to the right of number 4, number 5 is the successor. Now let's consider the number 0, for example. If I go one number to the left of number 0, I encounter -1. This is the predecessor of 0. If I go one number to the right of number 0, I encounter 1, which is the successor. Now let's consider a negative number. For instance, let's take -4. If I go one number to the left of -4, I come to -5, which is the predecessor. If I go one number to the right of -4, I come to -3, which is the successor. So all the numbers, no matter whether they are negative integers, 0 or positive integers, all the numbers on this number line of integers have a predecessor and a successor. The predecessor is 1 less than the number. The successor of a number is 1 more than the number. Though that is the basic concept. Now, using this basic concept of predecessors and successors, we can now understand how the greater than and less than relation actually works across this whole number line. Let's again start with a very simple example. Let's consider the number 4. All the numbers to the right of this number 4, 5, 6, 7, 8 till infinity, all the numbers are actually greater than number 4 itself. That is the first thing. The number 4 is actually equal to number 4, which is very, very simple. All the numbers to the left of this number 4, 3, 2, 1, 0 till minus infinity, okay, -1, -2 till minus infinity. All the numbers to the left of this number 4 are actually less than the number 4 itself. So that is how the relation on this number line, the less than, greater than and equal to relation on this number line works. So if you have a question on this, you should on the relation, on the comparison of integers, you should always consider this number line. Let's now take the example of 0. All the numbers to the right of 0, 1, 2, 3 till infinity are actually greater than 0. All the numbers to the left of 0, -1, -2 until minus infinity are actually less than 0. And the 0 itself is of course equal to 0. So that is very, very simple. The equal to relation just works out. Let's now take a third example and consider a negative number. Let's take -4 for example. All the numbers to the left of -4, -5, -6 until minus infinity, okay, all these numbers are actually less than -4. All the numbers to the right of this -4, -3, -2, 0, 1, 2, 3 till positive infinity, all these numbers to the right of -4 are actually greater than -4. Very, very simple, okay. Numbers to the right are greater than the given number. The number of course is equal to the number itself. All the numbers to the left are less than the given number. Very, very simple if you understand the concept of the number line. Now, based on this, let's consider some relations, some very, very simple comparison relations on this number line, some generalized relations. The first thing is every positive integer is larger than every negative integer, which is a given, right? Because all the positive integers lie to the right of the negative integers. So these are all negative integers and all positive integers are towards the right, and therefore these numbers, the positive integers, are therefore all bigger than the negative integers. That is the first thing. What is the next relation? 0 is less than all the positive integers. So each and every, no matter which positive integer I consider, so no matter whether I consider 1, 2, 3, whatever positive integer until infinity, 0 is less than all of these positive integers. That is a very simple relation. Similarly, 0 is larger than any negative integer. So all the negative integers lie to the left of 0, and therefore 0 is, so all of these negative integers -1, -2, all of them are to the left of this number 0, and therefore 0 is larger than all the negative integers. Very simple. Now 0 itself is neither a positive integer nor a negative integer, it is just a 0. So negative integers start from -1 and go on till -infinity. Positive integers start from 1, 2, 3 and then go on to the positive infinity. 0 is neither a positive integer nor a negative integer, it is just 0, that is it. If I go further away from 0 towards the right, I encounter bigger and bigger numbers. Okay, so bigger and bigger, the value of the number becomes bigger and bigger, larger and larger as I go further away towards the right from 0. The value of a number reduces, the numbers reduce in value as I go further to the left of 0. The further I move from 0, I'll encounter smaller and smaller numbers. So I come to -5, which is less than -1. Then I'll encounter -9, which is less than -5 also. Then I'll encounter -100, which is less than all -8, -9. So as I go further and further away from 0 towards the left, I am encountering smaller and smaller numbers. Okay, so that was the last rule. As I go further away from 0 on the left, I'll encounter smaller and smaller numbers. If I go further away from 0 towards the right, I'll encounter larger and larger numbers. See, very simple relations. Keep these concepts in your head very straight, and you'll never be able to make a mistake in comparison questions. They are actually very simple. Let's just now look at addition of integers. So we'll be using an analogy to understand the addition of integers very well, and our analogy is actually very simple. So here we have certain buttons. There are white as well as black buttons. White buttons, each of them denote a value of +1. Black buttons, each of them denote a value of -1. So that is what the value of these buttons it says. So if I have a total of, let's say, 4 white buttons, it is a value of +4. This is a value of +4. And if I have a total of 3 black buttons, then this denotes a value of -3. So this is what it says. The value is -3. 1, 2, 3, and of course each one of them is -1. So these are negative, so we put a negative sign to it. So very simple. Now at the same time, when we are doing these problems, we'll also use our analogy of account balances. So if you remember, we said that if I have a negative balance in my bank account, then is actually not the money, my real savings, but this actually denotes debt. So what does it mean? It means that I owe this much rupees. Okay, so negative balance is -1 would mean I owe 1 rupee to the bank. So I owe this much money to the bank. It is not my real savings. Positive balance, of course, it means my real savings. So these are my savings. So with that, and additional constraints, we are also placing 2 additional constraints. If I add positive numbers, it means that I am depositing money into my bank account. If I add negative numbers, it means that I am accruing additional debt. So I am borrowing more. So addition of negative number, that's what it means. So with that, let's start understanding each of these cases. They are very instructive. So pay close attention. So we have +4 here. And then on top of it, I made a deposit of 3 more rupees. So I added 3 more rupees to the bank account. So this is positive 3 I am adding, which means I am depositing 3 more rupees. So what does it mean? It means that I already had a balance of 4. I added 3 more rupees. So my total balance would now become 4 plus 3. And of course, this becomes 7. And of course, this would be positive because these are my total savings. My savings would actually increase because I made an additional deposit of 3 rupees. Very simple case. In the second case, I had a debt of 4 rupees, which is denoted by -4. Mind you, this is debt. So we put a minus sign. And I accrued an additional debt of 3 rupees. Okay, again, this is minus. I am taking more debt on top of the debt I already had. I am taking on more debt of 3 rupees. So in this case, of course, my total debt would increase. How much? So it will go up to 4 plus 3, which is 7. And of course, we will have to put a minus sign because it is my debt. It is not my net balance. So now in the next case, in the next case, what are we doing? We have a balance of 4 rupees and we are taking on a debt of 3 rupees. So this is my net balance 4 rupees and I am taking on a debt of 3 more rupees, or I am withdrawing 3 more rupees from the account. All of these 3 rupees that I am actually taking from the bank account, or the debt that I am taking from the account, can be fulfilled by my balance. So not only that, all these 3 rupees can be taken from the bank account, but additionally 1 rupee extra would be left in my bank account. So my balance would become +1. Okay, so all of these 3 rupees that I am withdrawing can be taken from my bank account, and I am still be left with 1 more rupee of balance. So that would be my final answer. In the last case, I only have 3 rupees in my bank account, but for some reason I need more money and I am taking on a debt of 4 rupees. So I am really doing -4. Okay, so this is +3 plus -4. This is the operation I am doing. In this case, the 3 rupees of debt would come from my bank account. They can easily come from my bank account, but this additional 1 rupee would have to be loaned by the bank. So this I would owe to the bank, and my net balance would now become -1. Okay, so those were the 4 cases. We understood those 4. Now let's come up with general rules of how we actually got the final answer. So in the first 2 cases, I am doing +4 +3, -4 -3. I am adding these 2 numbers. If you notice, what we have done is that the sign of both the operands is actually the same. So here on the top case, the sign of both operands was plus. In the bottom case, the sign of both the operands was minus. In that case, we simply add the 2 operands. So we do 4 + 3 7, and we write it here. Okay, if the sign of the operands is the same, we simply add the 2 operands and we take the sign and we put it right there at the answer. So if I add 2 negative numbers, my answer would become negative. If I add 2 positive numbers, my answer would really become positive. So that is very simple rule. If the operands are of the same sign, add the 2 operands and take the sign and put it in the answer. Very simple case. If the sign of the 2 operands, right? So if this was +4 and this was -3, this was +3 and this was -4. If the sign of the 2 operands is actually different, that the operands that we are adding is actually different, in that case, subtract the 2 operands, right? Again, very simple, not really complicated. So in each of these cases, the sign is different. In that case, we are subtracting the 2 operands. We are just taking a difference of those 2 operands. So we'll do 4 - 3, and that would be our magnitude of the answer. So the magnitude of the answer is 1 in each case. We are doing 4 - 3 here, and we are doing 4 - 3 here. And the sign that we use is that of the larger one. Okay, so the larger magnitude number, now larger of the 2 operands, we take the sign from there. So in each of the cases, the larger magnitude number is actually 4. So we take the sign of the 4. In the second case, the sign of the 4 is minus, and we put a minus sign. In the first case, the sign of the 4 is plus, so we use the plus sign. So that is the rule. If the operands are of the same sign, then just add the 2 operands together and use the sign in the final answer. If the operands are of different sign, then take the difference of the operands, in this case the difference is 1, and use the sign of the larger magnitude operand. So in each of these cases, the larger magnitude operand is 4, so we'll use the sign of the 4 in each of these cases. So those are the rules that we need to remember when we are adding 2 integers. Now we'll add these 2 integers. We'll do the same additions, but we'll use the number line, and we'll come up with this is our preferred method, right? Buttons we cannot draw in exam, so this is our preferred method. Either we'll solve it using number line or we'll solve it directly. Okay, so that is the thing. So listen to this thing very carefully. Again, we'll take the same 4 examples that we have taken so far. So in the first case, we are adding 2 positive numbers. So it is +4 and +3. The plus sign is actually optional. We don't have to write it. How would we do it on the number line? So we start with 4 because that is our first operand. So we start with 4, and our second operand is actually positive. So positive means that we move towards the right. So since this is +3, we move towards the right by 3. So 3 is our magnitude, and since our sign is positive, we move towards the right and we come to 7, and our answer becomes 7. In the second case, we start from -4. So we start from -4. That is not difficult. Okay, we always start from the first operand. That is simple. And here the magnitude of the number is 3, but its sign is negative. So this negative sign, what does it mean? It means that instead of going right, I would go left. So this negative would actually change the direction. So I start from -4 and I go left By how much? By 3. So I go left by 3 and I end up at -7. Now in the next case, we start with 4. So our starting point is 4 itself. But this time, in the first case, it was +3. In the third case, it is -3, which means that instead of going towards the right, we would go towards the left. Because our operand has a negative sign, it means that we'll go towards the left. So we go towards the left by how much? This time also we'll go by 3 only, and we end up at 1. So that is our answer. In the last and final case, we start with 3. So we'll start with 3 and then we'll go 4 places. In which direction? Because our 4 is negative, there is a minus sign, we'll again go towards the left. Very, very simple. If you are approaching this problem systematically. So we'll go 4 places to the left and we'll end up at -1. So what is the rule here? Rule is very, very simple. Start from the first operand. If the second operand is positive, go towards the right. If the second operand is negative, go towards the left. Take as many jumps as the magnitude of the second operand and you will come at the right answer automatically. The properties that we have looked at so far, which was the additive inverse and the additive identity, they apply to the set of integers. Now let's just look at the properties specific to the addition of the integer. So the first property and the most basic property is that of the closure property of addition of integers. So what does that mean? It means that if I take any two integers, let's say -5 and +3 or just 3, and I do an addition over those two, then my answer would necessarily be an integer. So that is the closure property. Similar to the closure property of whole numbers, it says that no matter which two integers I take, if I add them together, the answer would necessarily be an integer, and that is to be expected, right? Because as we saw, in the case of addition of integers, all we are doing is that we are adding and subtracting this magnitude. That is all we are doing, and that would only result in an integer. And then we are changing the sign based on the operands. Again, that would always result in an integer. So there is no operation involved in the addition which could ever take us outside the realm of integers, as long as my two operands are integers, and that is the closure property of addition of integers. Next property is the commutative property of integers. And what does it say? It says that if I have two operands, let's say again -5 and +3, and if I change the order of those two operands around the plus sign, so now I would write it in a different order. If I change the order of operands, it does not matter. My answer would still be -2. And again, that is to be expected as well. Because if you think about it, all we are doing in generating this answer is that we are looking at the signs of two operands irrespective of their order. We are simply looking at their signs. We found them to be different. Then we are taking the difference of those two operands, again irrespective of the order. So the difference in both of these cases would simply be just 2. And then finally, we are using the sign from the larger magnitude operand. Again, that wouldn't change from this case to this case. Just by changing the order of operands would not change the larger magnitude operand. That would remain -5 here, 5 here also, and -5 here also. So my answer will take on the minus sign. Again, to take another example of commutativity, let's just pick the two operands which have the same sign. So again, I choose two operands, -5 and -3 in this case. Now I change the order of those two operands. And let's see what my answers would be. In both of these cases, the way I generate the answer is we look at the signs, they are the same. I'll simply add the two operands and that would be my magnitude. In both of these cases, that magnitude would remain 8 only. And the sign again in both of these cases will remain the same because I simply pick up the sign of the two operands which happens to be the same in both of these cases. So in the nutshell, just by changing whether our sign is different or the same, just by changing the order of these two operands, whether they are of the same sign or different sign, just by changing the order of these two operands around the plus sign, I cannot change my answer, and this means that addition of integers is commutative. So that is the commutativity of addition of integers. The next and the most important, again a very important property, is that of associativity. Associative. So similar to the whole number, addition of whole numbers, even in case of integer, the addition is associative. What does that mean? Let's take a simple example. We'll take an example of, we'll add 3 integers. So instead of just taking 2 integers now, we will be adding 3 integers. And now I'll associate the middle integer either with the first plus sign or with the second plus sign. So let's just write down the expression in the first case. What would that be? In this case, my 3 would go with this, the first plus sign, and the 4 would remain alone. In the second case, okay, so this is a square bracket. In the second case, my 3 would go with the second plus sign. Okay, so this is, I changed the color just to make it clear that this is a different expression. Okay, and my 2 in this case would remain alone because my 3 went ahead and joined with this plus sign with the -4. So those are the 2 cases. Let's just solve them and see what the answers are in these 2 cases. So in the first case, it is -2 plus 3. The signs of 2 operands are different. So I take the difference and I use the sign of the larger magnitude, which is just plus, and this is minus of 4. Of course, again, the signs of the 2 operands are different. So I will take the difference of them, and that is 3, and the larger magnitude operand is 4. So I'll pick up the minus sign. In the second case, let's see what happens. The -2 will come as is, and now I'll take a difference of these 2 again because the signs are different. So I'll take a difference, and that would be 1. The sign of the answer would come from the larger magnitude operand, which is minus. Now the signs of these 2 operands around plus becomes same. So I'll just add them together, and of course we'll copy over the sign of the operands to the final answer, and that is a minus. So my answer really does not change whether I associated the middle operand with the first minus sign, first plus sign, or with the second plus sign. This means that addition of integers is indeed associative as well. So the 3 properties which we saw were true for whole numbers, addition of whole numbers, are also true for the addition of integers. Now with this, we have covered all the details of the addition. Let's just look at their summary. The first and the most important rule, this is the method that we would be using all the time for doing the addition of integers. And this is the rule that you need to remember always. The rule is again very simple. If the 2 operands that we are adding together have the same sign, so on the top we have plus sign, at the bottom we have minus sign for both the operands, simply add the operands together. So we will get 7 in both the cases, and pick the sign of the operands and slap it or attach it to your answer. So in the first case it would be +7, in the second case it would be -7. If the 2 operands are of different sign, the bottom 2 cases, take the difference of the 2 operands, the 2 numbers, that is 1 in our example. The sign would come from the larger magnitude operand. So the larger magnitude operand provides the sign in both these cases. So very simple rule. Remember this, and this is our preferred method. If no method is specified, this is the method we would be using for solving all the problems of addition of integers. If you are specifically asked to solve the integer problems on a number line, then this is what we have to remember. You start with the first operand. When you are adding numbers on the number line, you start with the first operand. You jump by the second operand, by the magnitude of the second operand. That is the number of jumps you will take. And the direction of the jump is given by the sign of the second operand. So the sign of the second operand is positive, you jump towards the right. If the second operand, the sign is negative, you jump towards the left. So all of these 3 cases will jump towards the left. And we have seen that these answers, how they come about. The last 2 and the final, and again very important properties for your Olympiad, mind you, are these 2. If I add a positive integer, no matter whether my starting integer was negative or positive, if I am adding a positive integer, as in this case, as in the first case, only one case we have where we are adding the positive integer, the final answer, that is this one, is greater than the number that we started with. And that is to be expected, right? Because if I am adding positive integers, I am jumping towards the right, so my final answer would be definitely bigger than my starting answer, because towards the right the numbers would always increase, the integers would always increase. If I am adding a negative integer, which is the bottom 3 cases, these 3 cases, if I am adding negative integer, in each case, my final answer would be less than the starting number. Why is that the case? Because we are adding negative integer. So we are jumping towards the left in each of these cases. And if we are jumping towards the left, my final answer would definitely be smaller. Towards the left, the numbers would, on the number line, the numbers would become smaller. So my final answer would definitely be smaller than the number I started with. So this is the number I started with. I am adding negative integers in all of these three cases, and all of these three cases, my final answer happens, or it does not happen, but it is indeed smaller than the number I started with. This slide is the most important. This animation, this thing, these rules are the most important for addition, and you should remember all of these. Very, very important. Now, based on this, let's just solve some problems. The first two problems that we'll deal with are the problems of the number line. So they don't have to do anything specifically with the addition, but they are just understanding how the number line of the integers it really works. So the first problem says that let's find a number which is 5 more than minus 5. So we start with the number minus 5, and I have to do 5 more, which means that I have to add plus 5. To add plus 5, we know that we have to move or jump towards the right by magnitude, that is by 5. And when we do 5 jumps, we come to 0. So this answer comes out to be 0. In the second problem, we have to do 3 less than minus 2. So now I start with minus 2. So my minus 2 is right here, and I have to do 3 less. Less means left. L in both the cases. 3 less means minus 3. Or you can simply remember that less has L, and therefore we go left. Okay, so from minus 2 we go 3 left, 1, 2 and 3, and we come to minus 5. So the answer in this case would be minus 5. The answer in this case was 0. The next two sums are actually the problems of addition. The very first one we'll solve using the number line. Okay, so the next problem we are solving using the number line. So let's clear that up. So we start with minus 2 and we do jump of 8. So we'll start with minus 2 and we'll do jump of 8. In which direction? Because 8 is positive, we'll go towards the right and take 8 jumps. 3, 4, 5, 6, 7 and 8. So we end up at 6. Now from 6, we have to again jump 4 by 4. In which direction? Because 4 is negative, we have minus 4 here. So we go left, so we go back. So we do 1, 2, 3 and then 4. And we end up at number 2. So the answer in this case is just 2. Very, very simple. Now we can solve the same problem by just using the properties, just by using the addition without using the number line itself. So how would we do that? Very, very simple. First I'll do minus 2 plus 8 and then plus minus 4. So first I do this addition. Okay, I can do addition, whichever addition I want first, because the addition happens to be associative. So I can associate this 8 with this plus or this plus. I just chose it with the first one because that is more natural. And then here, since the two operands are of different sign, we will just subtract those two operands, and that would be my magnitude, and I pick up the sign of the larger number operand, which is plus. And then plus minus 4. Again the two operands are of different sign, so we'll just take their difference and we pick the sign from the plus 6, which gives me the answer of plus 2. Another way to do the same addition was to actually just combine these two negative terms directly. So simply I would just bring this positive term, this plus 8. There was only one term which was one number which was positive, that was plus 8. I just write it separately, and then I add these two negative terms first. So I'll get 4 plus 2, 6, and of course because they were negative to begin with, they will remain negative. So I combine all the positive terms and I combine all the negative terms, and then I add them together. But this addition, because it is happening between two numbers which are of different sign, we will first take their difference. So this will become 8 and minus 6. So this difference would be 2, and then we'll pick up the sign from the larger magnitude operand, which is 8 in this case. So sign would be plus 2. So in each of these cases, you can see my answer does not change, which it should not, because I have done correct addition here. So now the last and the final problem, and this problem of course cannot be solved on the number line. It would take us forever to construct a large number line. So we are going to solve it using the standard method that we have developed. Okay, so that is the method of the addition using the signs. Okay, and in this thing we will use our technique of combining all the negative numbers together. So these three are the negative terms. So I'll write 37 as is, and I'll combine all of these negative terms and I'll add them together. So of course the sign would remain negative because we start, all of these terms are negative, so my sign would be negative, and I'll add them together to get the magnitude of my answer. So if you add them together, the answer comes out to be 75. So now here I have one positive term and one negative term, and that is our standard method. This is the method we would be using. We'll combine all the negative terms and all the positive terms, and then finally we'll add them together. So now in this case, the two terms are of different sign. The two operands are of different signs. So first we'll have to take their difference. The difference is 38, and then we'll pick up the sign from the larger magnitude term, and this comes out to be minus. Again, these problems are very important. Addition of integers is very important. The problems are simple, they are scoring, and you should get a good grasp of this because they will be used throughout in your arithmetic, throughout in your algebra. These techniques we will be using again and again. So definitely practice. The links of how you will practice are given in the description below, and of course you can ask me any doubt that you have. Now we are very familiar with subtraction and the use of minus sign in case of subtraction. So I can do operations like 3 minus 2, and the answer I know is 1. So I had 3 rupees in my bank account, I withdrew 2 rupees, I will be left with just 1 rupee. So this is a use of minus sign for subtraction. So that is the first use. The second use of this minus sign is in negation. Here in this case, when I am writing things like minus 1, I have taken this 1 and I have applied minus sign to it. I have prepended it with minus sign, and this use of minus is known as negation. Okay, so this is subtraction, this is negation. Subtraction is done with 2 operands, negation is done with only 1 operand. I only need one number and I negate it. I change the meaning of that number, right? Because why? Because 1 is different and I negate it, I change it to minus 1, it becomes a completely different number. So I change 1 to minus 1 by negating it. Now subtraction we are really familiar with, so let's just focus on this negation for 1 second. So I have said that there are two numbers, 2 and minus 2. This 2 is just a normal number, it is on this side of the number line. To go to 2, I move right, we know that. Okay, from 0, if I go 2 places to the right, I'll reach 2. To reach minus 2, when I apply the negation to 2, to reach minus 2, I still need to traverse 2 places from 0, but I change the direction of my movement. So this negation operation, what does it do? It changes the direction of my movement. So from 0, now I have to move towards the left. Okay, so that is what I am doing. So 2 moved towards the right, minus 2 we moved towards the left. What happens if I apply 2 negations? If I do minus minus 2, what would happen in that case? See, the first minus would take me towards the left, the second minus would again change my direction. So with the second minus, as soon as I apply that, I would again start going towards the right, and it means that this minus minus 2 is actually equivalent to just 2. In both cases, in 2 and in case of minus minus 2, in both these cases, we are moving towards the right from 0, 2 places to the right, and we'll reach 2 itself. It means that if I apply even number of these negations, so 2 negations, 4 negations, it would give me back my original number. It is same as not applying any negation at all, just writing the positive number as is. If I apply odd number of these negations, it is same as just applying one negation. It is same as writing the negative number itself. These negative numbers are distinct. They have distinct meaning than the case of positive numbers. For example, in case of accounting in our bank balances, we said that minus 2 really means depth. Okay, minus 2 meant depth, and 2 was the real balance in my account. These were my savings. So this is the case of accounting. What about height? Height above sea level. If I am writing height above sea level, okay, sea level I can denote with 0. Height above sea level I can denote with positive numbers, and height below sea level is denoted by negative numbers. So positive numbers completely different than negative. They denote two different things. One denotes height above sea level, 2 is above sea level, -2 is below sea level. Similarly, in case of temperature, in temperature also same thing happens. Consider the case of 0 degree Celsius. If I want to increase temperature from 0 degree Celsius, for example, I increase by 2, then I'll reach 2 degrees Celsius, correct only? If I decrease the temperature from 0 degree Celsius, I reach -2 degrees Celsius. So this -2 and this +2 in case of degree Celsius is also completely different. So the number and its negation, the positive number 2 and the -2, they are completely different things. Even when we talk about symbolically in physics, accounting, they are completely different meanings. Even in case of mathematics, they are completely different. Now with this basic understanding of our sign of negation, so negation needs only one operand, we understood this. Even negations, they would cancel, we understood this. This negation, once we comprehend it, we can now understand expressions like 2 minus -2. In this case, the first operand, this minus, is actually a subtraction. The second one, the second operator, sorry, not the operand, the first operator is a subtraction. This first minus is really a subtraction. The second minus is actually a negation. So you have to be very clear that these two minuses, the use of minuses, are completely distinct. If it's applied on two operands, right, this minus is being applied on two operands. So this is one operand, this is second operand, and then it is subtraction. If it is applied only on one operand, only on one number, then it is negation. Now that we have looked at the two uses of the minus sign, it shouldn't be very confusing for us to understand the subtraction of the integers. Now subtraction of integers we'll understand, or we'll solve it in terms of addition. So that is very interesting. We'll convert the subtraction to addition of integers, and that's how we will be solving the subtraction problems. So let's understand the equivalence between the subtraction and the corresponding addition problem. We will do that using our same example, our example of bank balances and taking on debt and withdrawals. Okay, so that is the same analogy that we will be using again and again. As usual, negative bank balances mean that is my debt. Positive bank balances mean that those are my actual withdrawable savings. If I am doing -3, it means that I am withdrawing that much amount from my bank account. So that by that much, my bank account would actually decrease, my savings would actually decrease. We understand that. Now another way to decrease my savings is to actually take on more debt. Okay, if I have more debt, definitely my savings would decrease. So subtraction or withdrawal is actually the same as taking on more debt. These negative numbers, -3, means that I am taking or I am adding more debt, and that is same as actual withdrawal. So here on the left side we have the withdrawal, we have written the expression in terms of withdrawal. On the right side we have written the same expression in terms of increase of debt. So either we subtract 3 rupees or we take on an additional debt of 3 rupees. In both these cases, my actual savings of rupees 4 would decrease by the same amount. Those two things are exactly equivalent, and indeed they are. So the way to derive this equivalent expression is to change this minus sign to a plus. So that is the difference between here and here. We have changed this minus sign to a plus here, and this 3, that is the second operand, we have written its inverse here. So we have negated it. Negation would actually produce the inverse always. Okay, so we have written the inverse of the second operand here, and in this way we have produced the equivalent operation. So those two operations are exactly the same. We have seen that in case of the subtraction of positive integers. So our first operand, our second operand was positive in this case. In this example, this operand was actually positive. In the second case that we would be discussing now, our second operand is actually negative, and we'll understand how we are going to solve this problem. So now the way to read this problem is, let's look at the second problem first. I have a debt of 4 rupees. That's what negative balance means. I told you already. -4 means that I have a debt of 4 rupees. I owe the bank 4 rupees. But I am subtracting my debt, which means that I am paying off 3 rupees of that debt, right? So I am reducing this is a subtraction and this is again a debt. So from these 4 rupees debt, I am subtracting 3 rupees of debt. That is what this expression is actually meaning. Subtraction of debt is exactly equivalent to making a deposit. So if I pay off my debt or I make my deposit, in both of those cases I am actually increasing my savings, right? That is what we expect. So we'll use that analogy and solve this problem. So what we have done is, instead of solving for the minus sign, for the subtraction of debt, we are now looking at the addition of deposit or addition of savings. This minus and minus actually can be turned into a plus, because we know two negations would cancel each other and they would become a plus. And then this plus can actually be removed because I don't have to write plus 3, I can simply write 3. So these two expressions are again exactly the same. Here we have written then in terms of subtraction of debt, removal of debt, and here we have written the same thing in terms of depositing of the money of, right? So positive money I am depositing, which means that real money I am depositing into my bank account. Both of these operations, either this one or this one, would increase my savings by the same amount, and they are exactly equivalent operations. Again, to come from this side to this side, what I have done, I have changed this minus to a plus. So I have converted the subtraction into an addition like I did before, and I have written the inverse of the second operand. So this was minus 3, and minus 3 I have written its inverse, which is just 3. So the rule for converting the subtraction into an addition, that is what we would be doing for now, from now on, is to actually change this minus sign to a plus sign. That is what we are doing in each of these cases. Okay, we change the operand, the middle operand, to a plus sign. From minus we change to plus, and at the same time we convert the second operand to its inverse. And these expressions are not only equivalent mathematically, they are actually equivalent in the real world also. In terms of depth, in terms of height, these two expressions are exactly equivalent. So again, the rules are: add the additive inverse of the subtrahend. So the subtrahend is the second operand. So instead of subtracting the second operand, we will add the additive inverse of the second operand. So that is the operation that we would be doing in case of subtraction. If I am subtracting a positive integer, as I am doing in this case, I was subtracting a positive integer, my result would necessarily 100% be lower, and we can verify that. So for example, here I am doing 4 minus 3, so my result would actually be 1. This is minus 4 minus 3, so I am taking on more debt, so my result would be minus 7. So this minus 7 is less than minus 4, and this 1 is actually less than 4. Both 1 and minus 7 are more towards the left than the operand that we started in each case. So when I subtract a positive integer, I am subtracting a positive integer in each of these cases. When I subtract a positive integer, my final result is actually smaller. When I subtract a negative integer, like the top cases, it means that I am actually paying off my debt. I am removing my debt. So naturally, my result, my savings should actually increase, and that is what happens. So in the first case, my answer becomes 7. In the second case, when I do minus 4 and plus 3, you can use the addition on the number line to confirm this, but my answer actually comes out to be minus 1 in this case. In each of these cases, the top two, my final result is greater than the number that I started with, because the final result lies towards the right on the integer number line. So these are the 3 rules, very important, very important, especially the bottom 2 rules for your Olympiad problem become very important. So keep those in mind. Now let's look at the property of this subtraction of integers. So we already know the subtraction of whole numbers, it follows, it is not closed. Okay, so we saw the subtraction of whole numbers already, we understood that. So let's say that I was to do 4 minus 3, the answer comes out to be 1. If I were to do 3 minus 4, then this answer comes out to be minus 1. So in the first case, my answer was a whole number. In the second case, my answer, when I did this subtraction 3 minus 4, my answer came out to be minus 1, which is not a whole number, mind you. So in case of subtraction of whole numbers, it was not closed, but in the case of subtraction of integers, it is closed. Why is that? Because this minus 1, although it was not a whole number, it is still an integer, which means that if I take any two integers and I do the operation of subtraction on them, my final answer would necessarily 100% be an integer. Since my final answer is always an integer, if I start with integer and do the subtraction, we say that subtraction is closed with respect to integers. Now, what about the commutativity and associativity of subtraction? See, these two cases, when I'm doing 4 minus 3, if I change the order of operands around this minus sign, my answer actually changes, which means that the subtraction is not commutative. If I change the order of operands around the minus sign, my answer changes. So subtraction is not commutative. Is it associative? It is not associative either. So for example, if I were to do 4 minus 2 minus 1, and then I were to do this 2, if I associate with this operator here, or if I associate this 2 with the other operator, my answer in both cases would be different. So my subtraction is neither associative nor commutative. But if I were to convert this subtraction into corresponding addition, right? So for example, let's say that I wrote 4 minus 3. What would be the corresponding addition? All we have to do is that we have to change this minus to a plus, and I have to write the inverse of this number. That is how I change it. We know that. Now this addition is actually commutative. It is not only commutative, it is also associative. We know that. And now I can use the property, commutative property of addition, to write it like this. So these two numbers are exactly equivalent, and you can confirm this by plotting these on number line, by solving this on number line, but answer in both of these cases is 1. So let's just do it. So we start with 4 and we go. So we start with 4, and this minus 3 says that we need to go towards the left side. So we go towards the left side and we end up at 1. So this first one we end up at 1. What about the second one? We start with minus 3 and this plus 4, since it is positive, it is saying that we need to go towards the right. So we go towards the right by how much? 1, 2, 3, 4, and magically we end up at the same place. We end up at 1. So by changing this subtraction into an addition, we were able to make it commutative. So addition is commutative, we know that. And similarly, we can also prove that by changing the subtraction to an addition, we can also make it associative. So subtraction by itself is not commutative, not associative. It is only closed with respect to integers. However, we can make it commutative and associative by changing it to by changing the subtraction to addition. And this is very important property. We would be using extensively this property by converting into addition. And we will be using it extensively in algebra. So keep this in mind, practice some problems on this, very, very important. Now with this, we understand all the properties of subtraction, all that is to know about subtraction. Let's try to solve some problems based on subtraction. Again, not very difficult problems, very, very simple. Approach it systematically. So here we have our first problem, minus 10 minus 4. All we need to do in this case is we need to change this minus to a plus, and this minus 4, I would write its inverse here. So instead of minus 4, I would write just 4. And now we have converted into equivalent addition, which we know how to solve. So this, here there is a minus, here there is a plus. So the two operands are of different signs. So we'll take their difference. The difference of 10 and 4 is 6. The sign would come from the larger magnitude operand, which is 10 in this case. So sign would be negative. Very, very simple, systematically. Okay, that is the thing. Do this problem systematically. Again, here we have two subtractions, but again we'll convert them to additions. So what we'll do is we'll write the second problem as 50. This is minus, this will become a plus, and the second operand, which was minus 40, will take its inverse, which would just become 40. This minus would again be written as a plus. The second operand is a minus, will again take its inverse and will convert into a plus. Okay, so plus sign is optional. We don't have to write plus 2, we can simply write 2. Okay, so now this subtraction of the integers has become a very, very simple, a trivial addition. This addition we can simply do. 50 plus 40 is equal to 90. And of course, since both the signs are positive, we'll just add it and we'll carry over the sign directly to the answer. And of course, this is 2. And then again, these two numbers are both positive. We'll simply add them together and we'll carry over the sign, which is plus in both these cases. So this answer comes out to be plus 92. As I said before, keep the concepts very clear, keep these rules very clear, and you will be able to solve each and every problem related to integers. They are not difficult. The only reason why students become confused is because they cannot convert, they are not able to convert the minus into a plus. So they are not able to convert the subtraction into the corresponding addition. So practice that well and you will be all set, because addition in turn is very simple. So practice some problems. If you have questions or doubts, put them in the comments below. With this, we have covered all the various operations, the addition and subtraction that we can do on integers. We have also covered their properties, and we have actually understood what integers really are. What do they signify physically as well as mathematically? But what we are left with, what is left to do, and of course that is also very important, is the multiplication of integers. Multiplications and division of integers we have not really discussed. Another very important thing closely related to integers is the absolute value operation. Again, very important. You can expect problems on this, especially in the Olympiad. They are their favorite topics because they are not covered in NCERT. So they become very important for Olympiads, and we have classes on those. So definitely check those out if you are preparing for Olympiads.